Welcome to aminacademy.com. In electrical engineering, let us discuss about resistors in parallel. Resistors are said to be connected together in parallel when both of their terminals are respectively connected to each terminal of the other resistor or resistors. Here, look at this. These terminals are terminal point is A and B, and each terminal, one end of resistors is connected one terminal and the other end is other terminal. Like the second resistor is connected, one end is connected to one terminal, other end is connected to other terminal. Like the resistors are connected in this manner, we can see these resistors are connected in parallel. In parallel circuit, we know that total voltage is not distributed. Here, suppose here total main voltage is 12 volt. Each resistor having voltage is 12. In this, each resistor have different current. That is, here resistor 1 have I1, resistor 2 have I2, resistor 3 have I3. In parallel circuit, we can say voltage is not dropped everywhere, same voltage, and current is dropped everywhere. The current is distributed. Here, resistors in parallel formula. Resistors offer resistance to the flow of current in circuit. The effective resistance depends on the connection, whether it is connected in series or parallel. In a series connection, the current will be constant, whereas in parallel connection, voltage will be constant through the circuit. So, in household appliances, parallel connection is preferred because each appliances should have different control. That means different switches you have to use for appliances. That means we can on and off with our individual preference. The formula for resistors in parallel is 1 by Rp, that is total resistance. Reciprocal of total resistance is equal to sum of the reciprocal of individual resistance. So for 1 over Rp equal 1 over R1 plus 1 over R2 like 1 over Rn. Then after that you have to find the reciprocal of that answer. We can get total resistance. For example, calculate the resultant resistance of a parallel circuit containing in 3 resistors of R1 is 2 ohms, R2 is 4 ohms and R3 is 6 ohms. Look at this. Here R1 is 3 ohm, R2 4, R3 is 6 ohm respectively. 1 by Rp, the formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by Rp is 1 by 2 plus 1 by 4, 1 plus 1 by 6. That here LCM is 12 because 2, 4, 6 is LCM is 12. Then adding this one is become 11 by 12. Then Rp is reciprocal of this 11 by 12 is 12 by 11. Therefore Rp is 12 divided by 11 is 1.0909 ohms. That means total effective resistance is 1.0909 ohms. Next question. Calculate total resistance of the given parallel connection. R1 is 4 ohms, R2 is 5 ohms, and also find the current of each resistance if circuit voltage is 100 volts. Here R1 is 4 ohms, R2 is 5 ohms. Formula of resistors in parallel is 1 by Rp equal to 1 by 4 plus 1 by 5, LCM is 20. Then 1 by Rp is 9 by 12. Then Rp is 12 by 9 is 2.2222 ohms. Now we have to find and also find the current for each resistors if circuit voltage is 100. Now here current is distributed. Therefore V equal to IR is the Ohm's law. From that I1 equal to V over R1. P is here 100 volts. R1 is 4. Therefore, which is current I1 is 25 amps. Then I2 is V by R2. V is here 100 over 5 is 20 amps. We calculated resistance current through each resistor. Here we can get it. Total resistance is total voltage by total current. Total voltage is here 100 divided by 75 plus 20 is 45. 100 by 45 we can get it these values. Now, so far we have done here about resistors in parallel with this is a common setup for resistance in parallel, and the total formula of effective resistance formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by Rn. Any number of resistors we can connect in parallel. Now we did 2 example problems regarding effective resistance, as well as through effective resistance we found current in individual resistors also. We have done. Please subscribe our YouTube channel.